Alright, so we are in section 9.2 where we get to graph and write equations of parabolas. We had, we've dealt with parabolas in the past in intermediate algebra, where we talked about writing quadratic equations and stuff like that. But this is more of being able to um, find more specific items that are directly related to parabolas itself in equations. So the definition of a parabola, which is up there, it's the set of all points equidistant from a fixed point, which is called a focus, and a fixed line, which is called the directrix. So if you look at the two graphs that I have to the right, I have one where it's y equals ax squared. So the general parabola looks kind of like this. It kind of opens up upward, and what that definition means is that we have a point which is like, say, like this 0, 0 is my vertex of the parabola. The focus is a point that's also on the same line as the vertex, so the point would be somewhere like located here, and they usually denote it by its distance p. And then it also says that it's equidistant by a fixed line, which is called the directrix. And so the directrix is a line that is away from the parabola. And what that definition means is that, let's, like, if I take the distance from this point, say right here, what that means is that the distance from here to here is the same distance from here to here. Now that may not look that way because I may have drawn the graph incorrectly, but that's what it's supposed to mean. So if I look at x equals ay squared, that's the difference is that the square variable is attached now to the y. And so what we used to have up and down parabolas, we're going to have left to right. So it looks something kind of like this, where the focus is here and the directrix is located here. Okay? So if I look in this box here where I have standard equations of a parabola with the vertex at the origin, we're denoted by two separate equations. The x squared equals 4py and y squared equals 4px. So what this will help us with is by figuring out the locations of the focus and the directrix. For this one here, the focus is at coordinates 0, comma p. So if p was 3, the focus would be at 0, comma 3. Okay? The directrix would be denoted as a line which is y equals a negative p. This is a horizontal line, and it's located at the negative p, whatever that may be. The axis of symmetry for this one would be x equals 0. And then these ones open up either upward, like this, or downward, or I'm sorry, I wrote that wrong. Let me erase that. I'm sorry. Or downward, like this. Okay? For the y squared equals 4px, the focus location, instead of it being 0, comma p, it's going to be p, comma 0. That's where that change comes in. The directrix, instead of it being y equals a negative p, it's going to be x equals a negative p. The axis of symmetry here would be y equals 0. And then it'll open up either like this or like that. So either like a left or a right type of opening. So here are some other things of classification. So if we make the assumption that the axis of symmetry is x equals 0, the vertex is 0, 0, the focus is 0, comma p, and the directrix is y equals a negative p, we can say that this type of parabola will have an upward direction, looking something kind of like this. The focus would be located here, In this case, it would be 0 comma p, whatever that may be, and then the directrix would be at y equals negative p. This is when p is greater than 0, so that's when p is a positive number. When p is a negative number, like it would be here, it's the same thing, except it's just a downward direction. The focus would be located here, and the directrix would be located here. If we dealt with the other side, where we have the y squared equals 4px, it looks like this. The positive one looks like this kind of a parabola with the focus located here and the directrix located somewhere here. And then the same thing goes for when it's p is a negative number, the parabola gets shifted and looks something kind of like this, where the focus is here, directrix is here. And I'll be able to explain more of that when we get more specific values. So for these examples, we want to graph the parabola given the following equations. I also want to label the focus and the directrix. So if I have example A here, I have x squared equals a negative 8y. So by looking at that, I see that my square is attached to the x squared. So it looks like the x squared equals 4py. So what I need to do is I need to find what p is. But I know what I can do is I know that 4p equals a negative 8. So if 4p equals negative 8, I can just divide both sides by 4. So my p equals a negative 2. So if I know that my p equals negative 2, that means my focus is going to be at coordinates 0, comma, negative 2. And my directrix is going to be at y equals a positive 2. So if I were to graph that, I'm going to go to 0, comma, negative 2 for the point of my focus, and then I'm going to go to y equals 2 for my directrix. And then it's going to look something like this. I'm not super concerned about the artwork of your parabola. I'm more concerned about the points that you have for your focus and directrix. If we look at B, what you need to do is make sure that you get the value that's got the square root, or they got the square in front of it by itself. So I'm going to add 1/2 x to both sides. Which that leaves me with y squared equals 1/2 x. So since this one looks like y squared equals 4px, I need to find what p is, but I know that 4p equals 1/2. So if I multiplied 1/4 to both sides, I would get p equals 1/8. So my focus for this particular equation is going to be 1/8, comma 0. And my directrix is going to equal x equals a negative 1/8. So let's just say that for simplicity things, each one of these squares is 1/8. Let's just say that, okay? So with that being said, that'll help us be able to graph it easier. So that means I can say that my focus is going to be at 1/8, comma 0, and my directrix is going to be at x equals a negative 1/8. And these deem the characteristics that are that our graph had in our general equations in the first one. Okay. Here they want us to write an equation of a parabola given the graph or given information, and the vertex is at 0, comma 0. Don't pay attention to this parabola. This one's wrong. I don't know. I couldn't get it correctly written, but the graph should look something kind of like this. But what it does tell you, the information, is that the focus is at 1/3, comma 0, and that the directrix is at x equals a negative 1/3. So if you look in your information that it is on page 1, we know that it's going to be like a y squared equals 4px type of situation. And we know that p equals 1/3. So if I replace 1/3 with p, and then I get to solve it, so my equation for this parabola is y squared equals 4 times 1/3, which gives me 4/3 x. Okay? For this example, I got 0. The focus that they give me is 0, 3. So if I look in the front of, I know that p is located in the y coordinate of the focus, so that's going to be an x squared equals 4py. And I know that p is 3, so I substitute that in, so my equation is going to be x squared equals 12y. For c, I have a focus of -1/4, 0, and I know that the p is located in the x coordinates, so now that's a y squared equals 4px type of equation. And I know that p equals a -1/4. So I substitute that in, so that means that my equation is going to be y squared equals, it's going to be a -1x, so I can just write that in as -x. Last two, they give us the point of the directrix. And we remember that the directrix, when we talk about when it deals with y and x, so this one's going to be y equals a -p. So that means in this case, p equals 5. And when I look in my back of my notes, when the directrix was y equals something, that dealt with an x squared equals 4py type of an equation. And so that means all I have to do now is substitute p in with 5. So now my equation will be x squared equals 20y. Last one, it is x equals 10. So that means that my p here is going to equal a -10. And since it's x equals, so that means that the equation I'm going to use is with the y squared equals 4px. Substitute in -10 in for p, so my equation is going to be x squared equals a -40x. And that is being able to graph and write equations of parabolas. Hope this helps. Until next time.